Now I'm going to explain about the ionization energy. So in the previous video we have explained about ionic radii and atomic radii, and I have compared the ionic and atomic radii also. So now in this video the next property we are going to see, that is the ionization energy. So ionization energy means it's simple, it is nothing that very limited minimum energy required to remove the outermost uh, electrons, we can say, from the atom. That is known as the ionization energy. Okay, so now I am going to remove this outermost electron. So for this removal of electron, very minimal energy is needed. That is known as the ionization. So when we remove that one electron from the outermost shell, what happens? The positive ion is formed, 1 plus. So the energy which is very minimal to remove the electron from the outermost shell of an atom to form a cation, that is known as the ionization energy. So now what happens during the along the period and down the group, we will see now. Okay, children, as the atomic size decreases from left to right in the periodic table, so starting from potassium, calcium, and towards the middle, that is transition elements, and when it reaches the last that is before the noble gases, bromine, from potassium to bromine, what is the ionization energy, whether it is increasing or decreasing? Let me see. First, potassium, the ionization energy is how much? It is 41 418. Now for calcium it is 589. There is an increase, isn't it? Now again for the scandium, what is that? It is 633. Then titanium, what is that? It is, yeah, 658. So the atomic size, when you move from left to right, the atomic size decreases whereas the ionization energy increases. Why is it so? It's mainly due to more energy is required to remove the electrons from the atoms, so that as we move along the period, the ionization energy increases. Okay, children, because there is atomic size is very decreased and the electrons are very close to the nucleus, and they are very more attractive towards the nucleus because the nucleus is having the protons, positive and negative charge attract each other, isn't it? So ionization energy is more when you move along the period. That is for the periods. Whereas when you move down the group, again see, now for example sodium I have chosen, the ionization energy is 495, and for the potassium it is 418. There is a decrease. I'm clear. The next is rubidium. What is that? It is 403. So it is decreasing down the group because as the atomic size increases, the valence electrons are loosely bound, so that there is a less energy required for the removal of the valence shell electrons. Understood? So the atomic radius and the ionization energy are inversely proportional, we can say, children. Yes, so the ionization energy decreases down the group whereas it is increasing along the periods. That's all for the ionization energy, children.